We're not looking at a probability, we're looking at a confidence level in here. And we want to be within a certain amount of confidence. So which one is the best statistic? This is your sample mean. This is what they call a point estimate. So when we have, again, the population versus sample, when we're looking at the mean, we're looking at the mu and the x bar. We're going to make, and this is what this whole thing is about, we're going to find out this information about your sample mean, and we're going to make an inference about this population mean. So we're going to be within a certain interval and a certain level of confidence that we will find your population mean in that interval. Not your sample mean, because your sample mean we were able to calculate. So when we get to these guys, these were just finding the ZC. When you find your ZC, remember, inverse norm. You want the middle part to be where that is. So inverse norm. So for instance, 1 minus 0.80 divided by 2. Use your standard normal. Mean of 0, standard deviation of 1. It will give you the negative, but you're going to give me the positive for your ZC. There's a nice little table in your notes. I would add these to your table. Just like if you do any more work with this, you'll have it on your table. Again, some of these are a little bit different. 0.97. We don't normally say 0.97, but it works the same way. This has to share 3%. So half of 3% is 1.5. So it's sharing, it's looking at a 1.5 area percentage-wise, which is small. Number 9, I forget which ones I gave you, but number 9, I just wanted to know what's the sampling error. Sampling error means just that. It says if I used your sample mean, but your population mean actually wasn't that, how much of an error do I have? And measure those errors in positive values, because they're actually distances on the number line. It's really not a formula for this. It's just like kind of just subtracting them, seeing what the difference would be. If I didn't hit this exactly on the nose, how far off was I? That's all it's asking you. 9 and 11 I gave you. Okay, then I gave you 13. 13 was just using your margin of error formula. It didn't give you a mean or anything that you would have needed, so you had to use just this formula. Again, you can go to your table for this, since we've been doing this so much. This is your 1 point. You're going to see the same ones. 90, 95, 99 is a big one, and maybe once in a while an 80, but most of these are 90, 95, 99s. So you're going to see the same ZCs coming back up again. You can put this straight in your calculator, straight in, and give me your margin of error, the same decimal places as your mean, which we don't have a mean. So as long as you have some kind of nice rounding, rounded to one decimal place, like your standard deviation, this will be rounded to 1.9. That one too. If you want to go one decimal place, 0.7. Okay with these? Stop me if you have any questions. These I like, because it just made you look for, they all have the same mean. It kind of would have been a little bit nicer if they put them all one underneath each other, so you could have seen actually who's wider, who's narrower. So you kind of have to look at your number line. You just have to match them up. Rule of thumb, the more confident you are, what happens to your interval? It gets wider. Just give me more wiggle room, because I need to be more confident. So go for the largest one. Start with C. Go for the biggest interval. So my biggest interval is probably, if you want to put them all on one, it might even help you. So C is your, 19 is this. Which one has the largest interval? Probably this guy, right? No. That looks like the largest one. So 19 is B, 20 is A. Oh, this one, sorry, this one's larger. 98 is your largest A, then this one is B. Your smallest one is 0.88. So just, if you have to, put them all together and you'll see it a little bit better. Okay? That's a good rule to remember that rule. Right here. Okay. This guy, again, I wanted an interval. Use your calc, use your margin of error formula. I rounded to 2 decimals. Why? Why did I round the interval to 2 decimals? The mean is 2 decimals. So you can use your formula. I will give you that formula. What I won't give you is this. That you have to know how to put your interval together. Did you have 23? Nope. Just 22. You guys were lucky. I didn't give you a lot. 25? Yep, 25 and 29. 25 is a good one because I gave you the end of the interval and it asked you to find the margin of error, right? So if you have the interval, you have to find the mean first. How do I find the mean between two numbers? The mean is the average. How do I find the average of two things? I add them together, divide by 2. And then the margin of error, just subtract. Just subtract. If you subtract the other way and it's negative, just make it positive. That was a good thinking problem. Sample size. Be careful on your sample size. How do I know what formulas I want? Because it says to me, find your sample size. Sample size is n. I pull up my n equals formula. I do not plug in 0.90. I plug in the z-score associated with 90%. I plug in my standard deviation over 1, so you don't even need the over 1. You can do it without that. Plug this in. Don't forget to square it. And what is my rule of thumb? Round up. Because if I round down, I would have never hit 125.1. Even though it's so tiny, I wouldn't have hit it. This guy too. Again. And then when you do this, make sure you round up. Notice like a margin of error of 1 is small. A margin of error of 2 is a little larger. So if you have more wiggle room, you don't need to be as more exact on your sample. Try to make sense out of these, because they actually make sense. Okay, and then I gave you 33. Okay, again it gave you an interval, and it wanted you to estimate the margin of error. So find the middle, make a number line, find the middle. Then once you find your mean, just subtract it from either end. You find your margin of error. It's kind of a nice problem. If you write the number line, you visualize it a little bit better. 36. And 36 randomly selected seawater samples, blah, 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 blah. Construct a 90 and a 95% interval. They have to give you your population standard deviation. They gave us our n. Pull out your information. N. This is your population standard deviation. I need to know that. And population, this should say population standard deviation. I don't know why I wrote S. Okay, construct, if you do it by your formulas, all's well and good. If you do it in your calculator, just tell me calculator. I want you to see what happens here. Sometimes making a number line is a little bit better. If I put my first one on a number line, so here's my mean. My mean was 23. So I'm going from 21 to 25. This is my 90%. Now my 95%, if you're going to get that exact, bring it out a little bit more decimal places. So where is my 95%? Here's a thought, guys. Watch. When I round this to here, they're both equal. So use the one a little not rounded. Because this one didn't have a decimal place, put a decimal place in here. You'll see the difference. Otherwise, they're going to look the same to you. because the mean has no decimal points. So put a decimal point in here. Otherwise, I'm looking at the same. So this is 21.2 to 24.8, and the other one went 20.8 to 25.2. In this case, I had to go out one decimal. Otherwise, it looks like it's the same interval. And use your calculator for that. This works wonderfully on your calculator. You already put the information in once, so it makes a little bit of a difference. Is there any question on this? This is a good one to make sure you understand. 45 is the next one. Did everybody put this in their L1 to find their mean? L1, you get your X bar, you had to put this in your L1. So you found your mean. Put your mean in there. Your mean was 24.1. How do I know how to round it to one decimal place? Because rule of thumb is round the mean one decimal place more than the X values. So therefore my margin of error should round to 1. And I should see I have a little bit more wiggle room on my 95%. If I need to be more confident, give me a wider interval. Don't tell me larger, tell me wider. Technically there's like infinite amount of numbers between your numbers. So larger really doesn't make sense. Wider gives me a little bit more leeway there. And the last one, 50, that some of you guys didn't like. Again, how do I know what I'm looking for? I'm looking for a sample size. Determine the minimum required sample size. Sample size is n. Pull up your n formula. Don't put the 90 in, put the ZC for 90. My population standard deviation. Now all I'm missing is my margin of error. Go back to the words right here. Within 1 year. Within 1 year means this way 1 year, that way 1 year. You could be older 1 year, younger 1 year. That's the same as your margin of error. And do you need to put this in when you multiply this? No. And make sure you round up. This is changing from here to here. So what changes when I get more confident? Okay. See what happens here? I need to be more confident. Give me more in my sample. I need to make sure I get this. Give me a little more in my sample. So the higher level of confidence is a higher sample size. Now, if I should ask you that question on the quiz, and I say, what happens when your sample size gets larger, and it's just a random question, can I just go to my calculator and put the same data in but change my n and see what happens to my interval? Wouldn't that be the best thing for me to do? Just put any scenario in there and just see what happens to your interval, or use one of the other problems there and change the sample size. So tomorrow you're having a quiz.